Alright, so a quick review of the definition. So if A is an n by n matrix with cofactor matrix C, then the determinant is obtained by expanding across either the first row, the second row, or any column, the result of just multiplying those corresponding entries. So multiply all the entries of the first row of the matrix A with the entries of the first row of its cofactor matrix, or multiply all of the entries of the second row of the matrix with the second row of the cofactor matrix. Alright, so let's do an example. In practice, you don't explicitly write out the cofactor matrix. We'll see how that works here. You just remember the meaning of it. So say 3, 1, 0, minus 2, minus 4, 3, 5, 4, minus 2. So if that's A, then let's calculate the determinant. Ultimately, we're going to take the entries of the row A and multiply them by certain numbers obtained from the cofactor matrix. So you can go across any row or any column. And so to make your life easier, you just pick a good row or a good column. And good, you want numbers that are easy to multiply. So let's expand across the first row. So then the determinant of this matrix A is given by, so we take the first entry, 3, and have to multiply that by the 1, 1 entry of the cofactor matrix. Now remember, the 1, 1 entry of the cofactor matrix is, by definition, it's going to be a positive number. I'll put big brackets here. It's going to be a positive number times the determinant of the submatrix. So if you remove the entry with that 3 there, the submatrix is minus 4, 3, 4, minus 2. Okay, so that is, I'm just writing explicitly what the number 3, this comes from A. So this number 3 here, this comes from the matrix A. And this thing here comes from the cofactor. Just by definition, the cofactor, the first entry of the cofactor is literally obtained by deleting the first row and first column and taking the determinant of that submatrix. Alright. Now what else do we have to do? Now we have to add to it the next entry of that first row. We have to multiply that times the cofactor. But now the cofactor will have this negative 1. So now it's the 1, 2 entry, so there's going to be a negative here, and it'll be times the determinant of the corresponding submatrix. So if you delete, so this 1 comes from here. So if you delete the first row and the second column, then you obtain this submatrix, minus 2, 3, 5, minus 2. Alright, and then the last entry is, if we expand across the first row, then the last entry would be that plus 0 times whatever. Plus 0, just to be complete, we'll say times the determinant. It'll be a positive now, and it'll be the determinant if we delete that 0 entry, so that's the first row, third column, we get minus 2, minus 4, 5, 4. So this is the formula for the determinant of A. Okay, so by expanding across the first row. So it's 3 times the determinant of the submatrix. It's going to be, then there's a 1, and then it'll be times negative, because that's how the sign rule works, the determinant of the corresponding submatrix, and it'll be 0 times positive determinant. So when you're calculating the what goes in front of these determinants of the submatrices, it's good to have this picture here. You have this picture. It always starts positive, and then it alternates. So this here will tell you the sign. So if you expand across the first row, so in our example, we expanded across the first row, so the 3 comes from there, the 1 comes from there, the 0 comes from there, and the final answer. And then we also will have these determinants of submatrices, but there's a certain sign, positive or negative, that goes in front of them. So the signs come from here, this positive is where that positive comes from. This negative is where that negative comes from. This positive is where that positive comes from. Anyways, of course we're not quite done, so we have to keep going. And then, so you see that the formula for the determinant of this 3 by 3 matrix is a summation of expressions that have determinants of 2 by 2 matrices. And then you can either use the formula that we have for the 2 by 2 matrix, or you can keep going. So how do you calculate the determinant of a 2 by 2 matrix? Well, you decompose it into, determinants of the 1 by 1 submatrices and so on and so forth. Now in practice, you don't actually do that. So let's just keep going. So this is equal to 3 times, I'll just rewrite everything, times the determinant of minus 4, 3, 4, minus 2. And that becomes minus 1 times the determinant of minus 2, 3, 5, minus 2. Okay, now we'll just use the formula. So the 2 by 2 matrix, you basically just cross multiply. So when you do that, you get minus 8, and then you get positive 8 minus 12, that's negative 4, and here, let me just write it out carefully. So the determinant is given by, you do minus 4 times minus 2 minus 3 times 4. That's the formula for a 2 by 2 matrix. Remember that the determinant of a 2 by 2 matrix is like you cross multiply. It's AD minus BC. It's the main diagonal minus the other diagonal. So minus, now what's this determinant? It's also minus 2 times minus 2 and minus 3 times 5. Again, just using the formula. Since we have a formula for a 2 by 2 matrix, we'll just use it. And so that's it. So that gives you 3, that gives you 8 minus 12 is minus 4, and that gives you minus, that's positive 4 minus 8 is also minus 4. That gives you minus 12 plus 4 is equal to, sorry, we're making a silly mistake. Yeah, I think I made a silly mistake. That's positive 4, oh, sorry, 15. I didn't do the subtraction properly. Sorry about that. So that's positive 4 minus 15, so that's negative 11. Sorry about that. So that becomes, that's negative 12 plus 11 is negative 1. Alright, so it's very tedious, but that's just how it is. So let me just rewrite what we have. So we have the determinant of this 3 by 3 matrix, which is 3, 1, 0, minus 2, minus 4, 3, 5, 4, minus 2 is the number negative 1. Okay, so that's by expanding across the first row or first column. Alright, so let's do another example. So here, this is the power of having all these different choices. So now we're going to do a 4 by 4 matrix. So basically that's going to be really tedious, but it won't be that bad. So to calculate the determinant of this, we can pick a row or a column to expand across. So to make our life easier, let's expand across this second column. We can go down, use any row or any column. So if we use, why is that convenient? Because that column only has a single entry. So when we calculate the determinant, we're going to be taking the entries I just circled times determinants of corresponding submatrices up to some sign. So when we're actually calculating the determinant, it'll be 0 times the determinant of some 3 by 3 matrix. So this ends up being not too bad. So I'll still write out the formula explicitly just so you can see. So we see the determinant of A, we expand across that, it'll be 0, and that'll be negative determinant. Because of its position, it gets a negative sign. of this 3 by 3 matrix. 3, 1, 2, 2, minus 2, 0, 2, 1, 1. But of course it doesn't matter because it's ultimately a 0. And then it's going to be plus 1 times the positive determinant. If you delete that, you get 1, 0, minus 1, 0, minus 2, 1, and 2, 0, 1. And then you get a plus 0. Again, because that entry will be negative determinant of the submatrix. If you delete that entry, the third 0 in yellow, then you get this matrix 1. So we have to avoid, we basically are just avoiding the yellow region, and then we have to eliminate one of the rows. So we're eliminating the, the third row. So that's what we get. But again, this doesn't matter because there's a 0 in front of all of this stuff. And then that entry, that's positive, negative, positive, negative, positive, negative, positive. So it'll be positive determinant of, if you delete that, you get 1, 3, 1, 0, 2, minus 2, minus 1, 2, 1. Okay, so of course there's zeros in front of most of these things, so really this just becomes 1 times the determinant of this 3 by 3 matrix. 1, 0, minus 1, 2, minus 2, 1, 2, 0, 1. So the determinant of the matrix A, which is this big 4 by 4 matrix, reduces to just calculating the determinant of this 3 by 3 matrix. Now to calculate the determinant of this 3 by 3 matrix, we can also proceed. I recommend that we expand. Again, you can expand across any row or column. So to continue, let's expand across the second column again. To continue, let's expand across the second column, because again, that has all these zeros. So when we expand across that, we'll get the entry 0 times, so now we're taking the determinant of a 3 by 3 matrix. So we'll get 0, and then we'll get minus 2 times the determinant of the submatrix. If you delete that 2 entry, then you'll get a 1, minus 1, 2, 1, and then you'll get a plus 0. So this ends up just being that, and we have a formula for the determinant of a 2 by 2 matrix. You just multiply the cross entries. 1 times 1 gives us 1, and then you subtract from it the off-diagonal entries. In this case, that gives you 2 times minus 1 is minus 2, 1 minus minus 2 is plus 2. So this is negative 6. Okay, so this is a great example to illustrate how this is like inductive. So your goal is to calculate the determinant of a 4 by 4 matrix. By expanding across any row or any column, it's going to be certain numbers plus or minus determinants of 3 by 3 matrices. Okay, then I calculate the determinants of the 3 by 3 matrix. You continue expanding, and you get certain numbers plus or minus determinants of 2 by 2 matrices, and you keep reducing it until you get to something very comfortable. And that is how you calculate the determinant of matrices.